Welcome to Brain Vision.
So we're continuing our work around physical chemistry here, and we're going to be taking a look at a distillation column. So the first thing we can calculate here, we will look at the molar flow rate. So the calculation we need for this is as follows. So then we just plug in our values. We get a value of 195 kilomole per hour. Continuing on, we have a molar flow rate of the residue. So we've just calculated for the feed. So now the molar flow rate for the residue, N equals NB, add ND. So what we have is 195 subtract 85, that leaves us with 110 kilomole per hour. Next we can look at the mole fraction. So the mole fraction, calculate using the following equation, n.0 xpd is equal to nb xpb, add nd xpd. So our mole fraction here is 0.405 mole. So moving on to the second part now. So we're solving for temperature. So our equation, 1 equals xp, add xh, then we can rearrange that because it is also equal to ypp divided by pp star tv, temperature, add yhp over ph star tv. So we rearrange for temperature, we find temperature, and it is 37.3 degrees Celsius. Once we've plugged in our values, the next thing we can take a look at is solving for the volumetric flow rate of the vapor out of the top of the column. V is equal to n dot VRT divided by PV. Plug in our values, we get a value of 4.33 times 10 to the 6 litres per hour. Continuing on, we can calculate the volume feed rate of the distillate. We have B dot D is equal to VPD, add VHD, which is equal to 7.76 times 10 to the 3 litres per hour. Moving on to part C, we're solving for temperature again. So we have this equation, P is equal to XPB PTR, add XHB PH TR. So we solve for TR. That is 66.6 degrees Celsius. So moving on to the next part, we're applying Raoult's law to pentane to solve for its mole fraction in the vapor boil-up. So what we have is YPBP is equal to XBPPTR. That can be rearranged, XPBPPTR over P. And then we solve for 0.103, and then we can look at hexane. So hexane is simply 1 minus 0.103, which would be 0.897. So we've just done propane and hexane, respectively. Moving on to the last part here. So what we have is the following. We're solving for D in this case. So what we have is A cross is equal to pi D squared over 4. So solving for D in this instance. And when we solve for D, we have root of 0.153 meters squared, which is equal to 0.391 meters. That is equal to D. So just to summarize now, so the assumptions that we've made in these calculations are the same ones provided in the statements of the vapor volume flow rate and the temperature calculations, that the pressure is 1 atmosphere and the Raoult's law applies to our components in this case. And so, as we mentioned in the calculations previously, assumptions are also made using the ideal gas law is valid and that the Antonin equation is also valid.